Hey, what's going on, guys? It's Others, your favorite finance teacher's pet. So I'm going to explain how to do question one. So the first thing I do when I get a data set that has a boatload of categorical variables is I go in and I create the different categories. So I'm going to do that for both floors and kitchen. So there's the simplex, duplex, and triplex. And then in order to parse out any categorical variables, it's the if command, right? So you're comparing the cell here, and in this case, make sure you have the quotes up to catch the right text. So we're saying if A2 here equals simplex, we want it to return 1, so if it's true, or 0 if it's not, right? Simply setting up your categorical variables. We're going to do that for each one of these variables here. So I've created my 3 categorical variables off of the number of floors, so just for ease of data viewing, go and hide it. Just make sure you do a dummy check to make sure your if commands work, so like you validate a duplex, simplex, and triplex entry, and then go ahead and hide it. And then you're going to do the same thing again for kitchen. The reason I'm doing this now for the end of it is because I think question 2 has you regress all of these. So just knock it all out at once. And again, you're going to do the same thing for modern, semi-modern, and typical. Whatever you label these variables here, that's going to be your variable output in the regression that we do later. So I'm going to go through and again do the if command. In this case here, make sure it just reflects the contents. 1 if it's true, 0 if it's not, and dummy check, right? I get the 1 output, and I'm going to go ahead and do it for all 3 now. Okay, so I've gone ahead and created my 3 categorical variables again for the kitchen quality. So I did my dummy check, right? Modern here outputs a 1, semi here outputs a 1, and typical here drops out a 1. So I'm going to go ahead and hide this because it's going to be freaking useless. And then the first question here asks us to regress both a linear and a nonlinear, so quadratic equation with living area. So in order to do the quadratic, I have to go ahead and create the square of this variable. Just makes it easier to do. Very simple. You just take that, compare it to the 2, drag and drop. Alright, and so now we're ready to do the first part of 1, right? That's if the relationship is linear or nonlinear in nature. So you go ahead and use your data analysis tool, get regression. Okay, so for the input y range, our dependent variable, in this case we're trying to predict price. And make sure you check labels. So you want to make sure your entire columns are properly labeled, especially when you get into multivariate analysis, because it's going to be really hard to tell what intercept is for what. And now I'm picking my X data. So this is the first part of the equation is simply sale price predictions on living area alone. So again, do that. And this outputs to my living area tab. I'm going to go back and do the same thing now. We'll go through the data here in a second. But I'm going to do it again for my nonlinear regression. Again, my input data range, my dependent variable here is price, and then now for the input, I want it to be both living area and living area squared. And then select it and make sure it's all grouped together. If it's not, it's going to get really pissed off at you. Alright, and this outputs this regression model. Right? So the first part of the question here is asking us, based on the regression coefficient statistics, is this price area between price area nonlinear? And if so, yes or no. So bottom line up front, it is. a nonlinear regression. How did I get there? So I will point you to session 7 slides. If you go to slide 32 here, if the coefficient on x squared is statistically significant, conclude nonlinear relationship. All right, so that's a reference-based answer. Our p-value here for living area squared is 1.35 times 10 to the minus 8. For all intents and purposes, 0. Typically, we use a 0.05 p-value, and therefore it is statistically significant. There are other factors you can compare, like r-squared values. You can get all sorts of stuff with the multiple R regression coefficients and all of that stuff. But based on the guidance of class, though this equation is statistically significant, which does make sense, in the living area squared, we have a statistically significant coefficient here. All right, so that's the first part of the question, and it says, if yes, draw a sketch of the shape of the relationship. So don't need to overthink this. I don't really memorize these, to be honest. I just make sure you can mathematically derive these shapes. But if you go to slide 38 from the session 7 PowerPoint, we know that my coefficients here on A, which is my non-squared term, and B, which is my squared term, are both positive values. I look at 4 here, both are positive, and that makes sense. I've got the opening cup of a, mirrored. I got the opening cup shape of a quadratic, and that is the shape of the relationship. And I think that pretty much answers question 1. If you guys have any questions on how I did any of this, feel free to reach out to me personally. And then I'll go through and explain 2 in another video.